right, hello and welcome everyone joining us online and on-site here today. Welcome to another session of the MZES Social Science Data Lab. My name is Dennis Cohn, and it's great to have you with us for another session in this event series at the Mannheim Center for European Social Research, where we explore innovative approaches to data and methods in the social sciences. Today's event is an input talk by Andreas Küpfer entitled Politics in Action, Studying Multimodal Data from Local Meetings to National Parliaments. Andreas is a postdoctoral researcher in the DFG project Analyzing Legislative Politics with Aligned Text, Audio, and Image Data at the Technical University of Darmstadt and a visiting researcher at the University of Birmingham. In his talk today, Andreas will present workflows for processing audiovisual data from plenary sessions across different institutional contexts. A quick note on the logistics of today's talk. The talk is live streamed and recorded in active speaker mode, which means for our on-site audience members today that if you ask a question, your audio will be recorded, and for our online participants that whenever you ask a question, not only your audio will be recorded, but in case your camera is turned on, your video will be recorded as well. Those joining us online, you may ask your questions by raising your hand or by posting your question in the Zoom chat, which I will then read out for you. And with that being said, it's great to have everyone on board. Great to have you here today, Andreas. And the floor is yours.
Yeah, thank you very much, Dennis. So thanks for being here and also thanks for being online. In my talk today, I would like to talk about two working papers. First working paper is about studying audiovisual data from local meetings, and the other working paper is about studying video recordings from national meetings like legislative debate. In the end, I would like to give a brief outlook on how we can manage even larger data sources and larger data sets with audiovisual data, but also other types of data. So this is why this talk is called Studying Multimodal Data from Local Meetings to National Parliaments. And to start with, to give a brief motivation, I just brought these 5 different examples of basically multimodal data. And this shows that political communication is multimodal because even this tweet combination of text and an image is multimodal data, right? Even though this is not audiovisual data, it's still multimodal data. And all these other examples here are multimodal data. If it's a school board meeting in the US or a video on TikTok from the US campaign, US presidential campaign, or the US State Supreme Court with a justice. And by the way, this video is from 1998 and it's available online and you can study it. Or obviously legislative debate in the German Bundestag. And all of this data unites. It's multimodal data, and we also see there is a lot of variety in these different data sources. And we have to carefully think about how we can analyze and study these data sources, and we have to implement tailored approaches to make sense of them. And this brings me to the first question: what can we actually learn from multimodal data, and where does it help us to advance political science studies? And I want to start with local politics on one end of the scale, basically. And in local politics, it is quite often about, in terms of multimodal data, it's quite often about rehydrating lost information. What does this mean? Basically, many institutions are forced by law to make their work transparent in any way. And for example, in Germany, this quite often means that you can attend some local meetings as a citizen. Sometimes they upload some agenda items or some minutes. And sometimes even upload video recordings. In the US, this is much more common to upload full video recordings of meetings from school boards, US Supreme Court, or city council meetings. But also, for example, in Mannheim, we have this, that they upload city council meetings to YouTube. And for the institutions, this has this one benefit that they do not have to post-process their meetings, extract data, write protocols and everything, but they can just say, okay, we upload this meeting online and everyone can watch it. And this means there is a lot of information in this, and for local politics, this might also mean that we can rehydrate parts of this information to use it in substantive political science studies. So this is local politics. For legislative debate, this looks quite different because quite often, and we already have some studies that look at legislative debate, we see that we can use much more fine-grained information from multimodal data, like video recordings from these debates. And this enables us to study different forms of political behavior. A lot of them are non-verbal political behavior, and lots of them look at, for example, vocal pitch as an indicator for emotional arousal, to capture phenomena that are not really visible in a unimodal approach, for example, in the plenary protocol. So this is the bandwidth coming from local politics to national politics or legislative debate. And we see already here that the data is really different. This leads us to the complexity of this data, because I already mentioned we have to carefully think about how we want to work with this data. And especially for multimodal data, we have to think of it as like each modality has its very unique structure. Text modality is completely different from the video modality, for example, in terms of how it is structured. And this is also why we should carefully think how we can combine these different modalities and make sense of it and extract features, for example, but also address substantive research questions. And then these modalities interplay. There is like an interplay between these modalities. Sometimes text modality rules out the video modality because lots of information is in a text modality and maybe not in a video modality for a certain phenomenon. So this is another aspect of multimodal data. And then finally, these video and audio qualities, they differ not only between institutions, we saw this already, for local politics and legislative debate, for example, but also within. So just imagine you have video data, like a database of videos of any political meeting, and it starts in the 2000s and it goes until today. Videos in the 2000s were definitely much different from videos you have today. So this is also something to keep in mind when working with multimodal data. And to start with, as this talk is about subnational politics, like also local politics and versus national legislative debate politics, I want to start with this first part. And I just brought 3 screenshots, 2 of them you know already. There is a third one, and all of this is subnational politics. We see, for example, these local politicians, they meet in a dining room discussing politics in a city council meeting. And this is an actual city council meeting in the US. And there are lots of them. And the quality differs. I mean, this is like obviously quite low quality in terms of video quality meeting, but there are also very high quality meetings. And to make sense of all of these meetings needs careful consideration. And then we have this justice again and a school board meeting, US school board meeting, which is kind of in between, I would say. Yeah. So this is like the variety of meetings. And then the good thing is that, first the bad thing, that data from subnational meetings is often not standardized. So there is no uniform reporting standard, for example, for meeting records like agenda items or transcripts, also not for roll call votes. But we have full archives of video recordings of these meetings, also on a subnational level for lots of institutions. And yeah, they are available online. And then more or less, like less of a technical point, subnational meetings also introduce a lot of variation. So if you think of it, like if you think again of the US, we see that they are distributed within a country. Like we have many US school boards. They are quite easy to, this makes it quite easy to correlate with regional factors and to address substantive questions. There is lots of over time change across institutions. For example, the school board composition changes over time. For example, like how many men and women are part of the school board, which introduces lots of interesting variation. And then we have also many different actors. So sometimes we see citizens speaking up during public comment in US school boards, which is also something we can measure in these meetings. But again, we just have the videos, right? So we have to automate the way we can first extract and then measure these phenomena we are interested in. So this brings me to the first actual working paper, which is a working paper with Miriam Holman and Tala Simcoe, where we address the question, what kinds of data can be extracted from subnational political meetings, and how can we use this data substantively in our research. And I mean, there are many more things you could extract from this type of data, or also this type of institutions, probably. But we focus on 3 or 4 main types, main things. We transcribe the data, we do speaker diarization, we can do a gender classification for all of the speakers, and also to regenerate, rehydrate agenda items, because they are partly lost for some institutions. And we can rehydrate them. And this is our pipeline. So we crawl videos from the source, either from YouTube or the websites from the institutions. And then we use for like 3 or 4 of the 4, we use the audio component, which leads us in the end to gender labels. And we also explore some of the visual features, which is quite challenging for these local meetings. And I can talk a bit more about this in a bit. So we focus on these 2 cases. From the US, we have a set of US school board meetings, around 1,000 hours of video material from 30 different school boards. So we really tried to have lots of variation in terms of gender composition of these school boards over time, but also within a school board, but also across school boards. And we use this US State Supreme Court meetings. So we first had to crawl them. And we again use a sample from 5 state Supreme Courts with data of around 30 years. So again, lots of variation in video and audio quality in this data set. So all in all, around close to 3,000 hours of video material, which we want to process with our pipeline. So about the relevance, I mean, we have these 2 cases, and both cases have very distinct things they can do and they can decide in US. First of all, school boards, for example, they can oversee and develop curriculum for schools, but they can also sometimes set local tax rates or approve capital projects. So very different things they can decide on and discuss about. And then obviously US Supreme Courts, which can even do more, for example, invalidate state laws sometimes, or executive actions. So these are the 2 cases, lots of variation within each case, but also between these cases in terms of how prominent they are also across the US. This brings me to the first feature. I talked about these 4 different features. This is the first one, transcription, which first of all sounds quite basic. I mean, yeah, okay, you transcribe a video, but we thought about we should think about this in a bit more detailed way, because we actually have transcriptions already for the YouTube videos. I mean, YouTube provides these subtitles, but can we really use them? Is it good enough? So we use WhisperX to transcribe all these videos from US school boards, but also from the state Supreme Courts. And what we see is, if you compare the Levenstein distance and cosine similarity, one high cosine similarity and a low Levenstein distance, with a manual coding, like a manual transcription, and if we have it for school boards with YouTube, we see that on average, the WhisperX performance is highest or lowest compared to the others. And this is also the case for the US State Supreme Courts, where we just rely on the manual codings because there is not a lot of videos on YouTube, right? So this is the first indicator that WhisperX really helps to make these transcriptions better. And for example, names are really often just wrongly transcribed. This is one thing, but also YouTube sometimes just say, okay, this audio quality is not good enough. I just ignore the next 2 minutes from this meeting. Which introduce some severe bias because, for example, older meetings have just a less good audio quality, right? And also hand codings of these, the manual codings, show that we are in 95-96% of all the words that we are correct with WhisperX. So this is the first part. We have the transcription. Now we add on this and say, okay, who speaks when? So we use PyNote to do a speaker diarization, which means we can basically automatically annotate speaker IDs for distinct speakers in a meeting. We can align those with, basically it lets us align the speaker changes with words. And this is just one example of like a speaker change. So speaker B061 starts to talk, and then they end, and then another speaker starts, A69C, and we see, okay, this Brex correctly finds, Pioneer correctly finds the speaker change here. And we also hand-coded those and checked, okay, did it really work well? And we are also at an accuracy of 95, 96% actually. So it works really well. There are some missings if there is just one word in between, or if there, I don't know, people chatting in the background, obviously, or if there, this is also one case, if there is a choir singing in a US school board, it's quite difficult to do a speaker diarization. And this happens sometimes, but these are really like exceptions, basically, which do not happen all the time. Well, this is the second part. The third part, which brings us more to the substantive interest of this paper, and also of the follow-up paper, which is going to be a substantial one, is what's the gender share of speech? And again, we don't have meta-information on this from like the institutions itself. So we have to rehydrate this information. And we can do this with a fine-tuned wave-to-whack model. So we can say we already have the segments of each speaker. So we just randomly sample 20 minutes of each speaker ID at maximum and assign gender to each speaker ID, which lets us rehydrate overall speech shares per gender. So this is the third feature, and the fourth feature we're interested in is agenda items and rehydration of agenda items, which is also quite straightforward using open weight LLMs. So we can say we feed in the full transcript into a LLM. We can either use a zero-shot or one-shot approach. Zero-shot approach means basically a one-shot approach basically just means we just give it like an example agenda structure. And what we expect from LLM is give us a title for agenda item, and also yield basically excerpt of the transcript where the new agenda, where the agenda item starts and where it ends, which lets us map this back to the actual transcription. Which helps us to first not only generate agenda items, but also align them with start endpoints to really show basically what's the salience of certain types of agenda items across meetings and over different meetings. Or if you're interested in public comments, this makes it possible to really trace the different persons that spoke about different topics during public comments across different meetings. And just to add one thing about the visual component, so all of this was about the audio component. We thought about what can we do with the visual component. So the idea was to work a bit with scene detection, to basically assess the complexity of different meetings and of different institutions, and also, for example, to extract frames where the school board is visible, to then in the next step extract facial action units, or do they actually pay attention to what is being talked about? And this is quite challenging with local political meetings, at least for these cases, because the video quality is not as good as for legislative debate, right? So there is some boundary reached, and also things like facial action units is not impossible, but really challenging, at least for these cases. So we stopped here and said, okay, we focus on the audio part, at least mostly in the paper, and think about what can we do with the audio and text part. And this is one example what you might want to do with the audio part, and with this rehydration approach. Gendered school board composition. So that's the gender composition of school boards translate into gendered speaking time during meetings. And so we hand-coded superintendents like at the year level for each school board, and the gender of board members, which were on the websites available, and the share of speech by women. so as a dependent variable in the model, and the predictor was the proportion of female board members. And so our unit of analysis is a single meeting in the data set, and we're interested in estimates for female versus male superintendents, because superintendents usually have a very high, like lots of speaking speaking time during a meeting. And these are our like preliminary results. And what we find is that there is some kind of tipping point of female proportion of board members for both cases, superintendent female and superintendent male. So this is the speaking time, the share of speech basically, and this is the proportion of board members, female proportion of board members. We see that if there is more, if there are more than half of the board members are women, there is a quite strong increase in expected share of speech by women. So this is just some first application in this paper, and we're working on more applications, or more like a substantive applications for next paper, from substantive paper. And with that, I would like to switch over a bit to what you can learn from legislative debate. And I mean, there are already papers on this. They look at like vocal pitch, for example, or also some gesture papers. The point is that this is mostly possible because national and also many state parliaments significantly differ from these local meetings. So we quite often already have cutted videos, and they are edited. They are available on the websites as well. The chair structures these meetings much more thoroughly. And also there are much more rules of procedure, which just makes it much more easy to study these meetings, or at least study the meetings on a more in more depth, basically. And I mean, we also have these plenary protocols where a lot of us already worked with in the past. And to just give some brief overview, I brought this little illustration, what you might want to extract from legislative debate meetings. I mean, from the audio part, we could also do the same with local politics, but from a video part perspective, this is quite restricted to legislative debate or to high quality political meetings. So for example, you can extract gaze directions, so you can see where a person where a person is looking at during a speech, for example. Or if you're interested in an audience, you could do the same with the audience. And also on this, there are already papers that look at this for some institutions, and you can also extend this. But this is just an overview of things you might want to extract from legislative debate. This brings me to the second working paper I want to talk about. Look who's confronting. This is part of my dissertation, and in this paper, I'm interested in eye contact seeking as a visual indicator of targeted behavior during legislative debate, right? And there are basically two main types of interactions in debate. If you think of it in the perspective of the speaker, the MP giving the speech, first of all, there is outgroup interactions, which are quite often related with and associated with dominance and confrontation, and in-group interactions with your own party, which are quite often associated with reassurance and affiliation, right? And we can measure these things with eye contact seeking, and I focus on eye contact seeking in this paper because eye contact itself is a very fundamental nonverbal act of interpersonal communication. We use it continuously. Also, right now I use eye contact, and same also do MPs in Parliament. They use eye contact all the time. And the good thing of eye contact is that we can infer from the eyes itself with whom we seek eye contact with. And this means it's directed. And this is a feature that many other measures and approaches do not have. And it's retrievable from the video component of legislative debate. So there are models which you can use to extract eye contact. So what's in a gaze, actually? And I already talked about this a bit, and there are lots of social psychology studies and experiments that ask the question, if someone seeks eye contact with you, what kind of things do you relate with that person? And these participants quite often say that in general, things like dominance, confrontation, probably leadership, but especially in competitive settings is this the case, and also that they display power and status. And this might have implications also for political processes and decisions and how we perceive these MPs that give a speech. And so we have again these out-group and in-group interactions, and these signals that show different types of, or that leads to different types of impressions from a speaker. First of all, confrontation, dominance, and second, for outgroups, reassurance and affiliation. So, and to test this and to take a look at this, at these dynamics, I look at a case study from German Bundestag. So I used around 15,000 speeches from the 19th German Parliament, which was the first with the far-right AfD. I use basically a fully multimodal approach. So I use all three modalities, but I want to focus on head pose here because this is the core of this project. And this is also what this illustration basically shows. So it shows the mapping of eye contact seeking, like the head pose, with different parties. So these windows can be mapped to a gaze direction. And it's not just the parties in parliament, but it's also the government bench. So you can also associate eye contact seeking with the government. So you can, so I look at different things like government opposition, like how often do opposition speakers look at the government during their speeches, and how often do they basically confront them and attack them. But I also focus on gender patterns and the far right and party competition in general. And for the next 4 slides, I think, I just want to give you a brief overview about some spotlights, what I do in the paper. And I want to start with this very first thing, this very first graph with a descriptive overview that basically shows the distribution of eye contact seeking for all parties in parliament, for both female and male MPs. So what it shows is, if you focus on the left party here, it shows starting from the left party to the SPD, to the Greens, to the Conservatives, the Liberals, and the AfD, and how often female and male MPs look to these parties on average. And we see that on average, this is the dashed line, MPs look straight ahead. So on average, you just give a speech and look straight ahead in this distributions. And this holds for all parties. Sometimes it's -1 degree, sometimes it's +1 degree, but it's on average very close to 0. And what we see here as well is that the distributions for female and male MPs are very different. Female MPs tend to look much more often just straight ahead, by that probably avoiding confrontation, but also avoiding just interactions with other parties. Then compared to male MPs, who much more often look to the left, to the right, and interact and speak to other parties in parliament. And also this holds for all parties, even though for the far right, it looks more similar than for the other parties. So this is a descriptive overview, and now I want to go into the same, but with a modeling approach. So I ran a multinomial logic model, calculated first differences. And what it shows is basically the probability, if it's positive, this means there is more eye contact by female MPs from a certain party with another party or looking straight ahead. And if it's negative, this means more eye contact by male MPs. And what we see is that straight ahead has around an average 15% higher probability for female MPs than for male MPs.
Yes, just a quick question for clarification. How do you distinguish straight ahead from Greens and CDU?
Yeah. So basically, if I go back here, I said I had basically a window for straight ahead, where I said this counts as straight ahead. So only this part for the Greens is still for the Greens, and starting from here, it counts as straight ahead, and the same goes for the conservatives. Otherwise, I would have had to like basically ignore the Greens and the AfD, Greens and the Conservatives completely. So this just helped me to still keep it in the data set or in the modeling approach, basically. Yeah. And yeah, so well, these are the gender patterns in this in this figure and this paper, and I think this you can infer quite a lot of things from this. For example, you could think of, we know that that there are gender patterns of interjections in Parliament, and if I correlate this, and I did this in the paper as well, with how many interjections a certain party did in during these speeches. This party attracts more attention, also visual attention, eye contact attention, basically, if there is another speech with less interjections. And probably these gender dynamics in interjections are correlated or have something to do with these looking straight ahead, higher looking straight ahead probability for female MPs than for male MPs. But this is something for next iterations to think about. So this is just, first of all, to show, okay, there is a big difference and a big gap and lots of gender patterns here. And it's also interesting to see that this also holds for the far right, right? Even though this, the estimates are a little bit smaller. Second, I talked a lot about in-group versus out-group, and you would expect that if in-group is more positively correlate with more positive words, you would expect higher sentiment than for out-group visual addressings, and this is the case. So if I look at seeking eye contact with competing parties and seeking eye contact with my own party, we see that sentiment is lower for competing parties and higher for own party, which just shows again, probably this is really about confrontation and dominance for out-group parties, and probably about reassurance and basically validation for in-group parties. So this was gender patterns, in-group versus out-group, party competition. And to give another spotlight, third spotlight, I want to quickly talk about negative sentiment with the far right, because also here we see these patterns, right? And we see that the blue dots show, blue bars basically show the sentiment for different parties. This is the speaking party with the far right. And the purple bars show the same, but for left party, and the black dots show it on overall, it's basically the baseline. And we see that if parties seek eye contact with the far right AfD during the speeches, the sentiment is less positive than the baseline, and that this is also not the case for the left party, even though it's also on the very left, which makes it a really, really good case to apply eye contact seeking, right? So this just basically is a stronger version of this one, and it shows that for the AfD there is even more in this and more in eye contact seeking, and that it's even more negative in terms of sentimental weights. I want to conclude with a brief outlook. So we talked a lot about local political meetings and video recordings. We talked a lot about legislative debate and their video recordings. And we have all of this data, right? So we have to make use of it and make sense of it. And in my outlook, I talk about how we can process all of this data, how we can crawl it, extract features, segment videos, and all of this. And this is why it is about workflow automation. And this is part of the DFG project I'm currently in, which is about a data set with more than 15,000 hours of speeches from all 16 German state parliaments and the German Bundestag. So lots of data. We thought about how can we efficiently process all of these videos. And the thing is, some of these videos, they're already cutted. Some of these videos, they are 10-hour-long videos, like sessions in Parliament. And we don't want to watch all of these videos, maybe some of them, but not all of them. So we want to find an approach, a methodological approach, to segment these videos on speech level, to identify and track speeches. So we want to assign speaker IDs, which we basically clustered speaker IDs, and also extract various kinds of multimodal features like gaze direction, facial action units, and so on. And for that, we introduce a new processing framework. The framework itself is basically already established, which is its approach coming from biology. And this helps us to basically implement all of this in a very modular way and to parallelize the processing of these different modules. Like one module might be facial action unit extraction, another module might be segmentation of a video into speeches. Which leads to parallelization of all of these different modules. And like 2 minutes, I can talk just quickly about how this helps and how this changes a lot in terms of inference time. And on the substantial side, there are two main questions we want to address in this project. First of all, how has parliamentary behavior changed with the presence of the far right? And because we have all of this data, we have it on state level, but also on a national level. And also how a conditional signal is expressed in audiovisual speech data. And this is how our current graph looks like. So this is like all of this is one module, and these models can be run in parallel. Because they can be run in parallel, this means that the inference time for 1 hour of video recordings is at about 4 minutes 20, which is quite fast for like speaking of how many features you want to extract. And I'm pretty confident that this is not limited to just this type of video, but you can also apply it to other types of video recordings or also other types of like data that is quite large and which you cannot watch or interact with completely. And this also brings me to my conclusion of this talk. So I started with multimodal political data that conveys a lot of variety in quality and structure. We saw this for local politics, which allows to reiterate a lot of, I call it high-level features, for example, the transcription or the gendered speech shares, which is also the case for legislative debate video recordings. But this also enables, like this type of video also enables the extraction of low-level features such as facial action units. And I showed this in this working paper with seeking eye contact. And finally, these modular workflow managers might really help to parallelize these tasks efficiently to process different sorts of multimodal or more general data, which is just too big to take a closer look at. Thank you very much. This brings me to an end, and I'm looking forward for your thoughts and comments and questions.
Hey, thank you very much, Andreas. We now have plenty of time for questions and comments. And I see Leon's hand.
Thank you for this presentation. Very interesting data you have there. One thought, just like it's not like criticism or anything, just one thought I had was when looking at the who do they look at when they did I understand correctly?
I can also
who do they look at when they're like when the sentiment is positive, and who do they look at when the sentiment is negative? Or was it?
You mean
it was one of the last few.
That one?
This one, yes.
Yeah.
How common is it that the sentiment is positive? I would imagine that's not too common in parliamentary speeches, right? At least intuitively, I would think that usually, at least in opposition, you're going to be criticizing instead of being positive. So do you have like any like rough idea how common that actually is?
I mean, the question is, what do we mean with like positive sentiment? I mean, if it's above 0, obviously we call it positive, but actually it's still on average maybe going more into negative because I mean, yeah, it's close to 0, so I would at least say maybe it's neutral on average, but I don't have numbers, to be honest, like how, like at least in this data set, how often it is actually negative or positive. I have to take a closer look at it. But that's a good point, yeah.
Range -1 to 1, or what's the range here?
No. It's like 0 to minus 0.1 down there.
No, I meant the whole sentiment range.
Yeah, whole sentiment range is -1
Yeah.
to 1.
Okay.
Yeah.
Okay, so it's
Yeah.
actually,
It's actually quite
Heather
close.
really has super strong.
Yeah.
Okay.
But I mean, you also have to see that there is like lots of data compressed in this one estimate. So yeah.
Okay, interesting. Yeah. Was that my question?
Just another clarifying question. I'm a little slow. Can you walk me through this graph? So like when the Social Democrats speak and they're looking at the AFD, their sentiment is more positive than when the AFD speaks and looks at the AFD?
I mean, it's quite similar, I would say. But actually, this is what the data says. Yeah.
Okay.
Yeah. But you also have to see, I mean, difference here is very marginal. So both is extremely close to 0. So yeah.
It's still like the most positive sentiment comes from the CDU when they
Yeah.
the AFD, right?
Yeah, exactly.
Okay.
Yeah.
No, understand.
And also that, I mean, like the core part of this slide is also to show that this is also not that there are not that systematic patterns for the left party if you compare it with the far right. But yeah, thanks.
Great. Then we have Julius.
Yes, thank you so much. This is very impressive stuff. I want to maybe ask your thoughts or clarification questions on the interpretation of the gendered effects in eye contact seeking. Because what really stood out to me is that it's male MPs also like looking at their own party more rather than looking ahead. So how can you explain this in this like dominance or like attacking sense? Or is this more of another story of maybe male and female MPs just communicate differently? So this general relation seeking is different, and maybe this looking straight ahead has some theatrical or like stylistic value in itself rather than just avoiding confrontation.
I mean, I would go more for the latter because I mean, we know that legislative debate in parliaments are quite a hostile environment, and this might be an explanation for this, that female MPs just more often tend to avoid eye contact at all, just looking straight ahead, even with their own parliament, because it probably triggers any kind of response or anything. But if they look at their own party, I would see it more as, at least in terms of male MPs, looking for, as I mentioned, a reassurance and potentially even signal some kind of leadership within their own party. But yeah, these are just some thoughts on why the result is as it is, and why these estimates are so clearly divided between male and female MPs. But I mean, yeah, if I would try to avoid eye contact, I would probably also look straight ahead and maybe also a little bit up. I mean, this would be also a next step to look at, because it's not only about looking left, right, but also looking like you can also measure with this approach whether someone is reading from their speech notes more often than other persons, or just looking above all the MPs, for example. Yeah. But thank you. It's a good thing. Yeah.
Your name, please.
Yes, Georg.
Georg, please.
Yeah, thank you very much. Super interesting work. I had a question that was partially answered already. How easy is it to distinguish between eye contact and head pose? Probably future work. And then the other question that I had was, could it be that the secondary use of the speeches as social media material influences where, like how you see the head poses, so that maybe some parties kind of try to look more straight because that will look better on social media than yeah.
Thank you. I mean, the first question, I also thought a lot about this. Like, obviously, I mean, my approach is about head pose. That's right, and I use it as a proxy for gaze direction. But if you like, watch these debates in Parliament, MPs most of the time really use their head to really address another party and not just like use their eyes and look to the left. So really also change the head pose. And your second question, and this is also something to investigate and something to look at. I would assume that MPs also strategically sometimes produce certain types of material to reuse it on social media. And during these like snippets they post on social media, they actively try to use lots of engagement. For example, when like there is this one excerpt from the AfD posted on TikTok where they actively show an MP addressing another party and yelling at the party basically, and also seeking eye contact with the party. So they basically also probably different parties use this as like an indicator for or opportunity to share emotional content, for example, because addressing someone always means, I mean, I interact with you and I produce emotions, right? Not only in like I'm emotional, but also I produce these emotions from my opponent or competing party or friend. Yeah.
Right, then I'll jump in with two questions. The first one, a quick one, and I think it relates to the previous comments. The camera itself is a factor, right? Because the camera itself is straight ahead, and people may want to communicate with a broader audience, and not so much with the plenary, the group of legislators in the room. So, is that something you could distinguish from the gaze direction, whether people look directly at the camera or actually at any section of the 180-degree parliament in front of them? And then the second question, and it may be the more critical one. So, I mean, let me preface this by saying that I think this is cool, right? This is cool because it tells us there's dimensions in audiovisual data that we can detect through automated workflow that we couldn't detect before. But, and this is my main objection at this point, right? You're kind of using gaze direction, which you interpret as a measure of confrontation. And to plausibilize that it's a measure of confrontation, you use pre-existing measures of confrontation, like the sentiment of the textual content of the speech. So the question is kind of, if we already have pre-existing measures of confrontation, why do we need a new one, right? And again, I'm saying this having very well in mind that down the road, these measures and techniques can be used for for endeavors that kind of push the boundaries. But at this point, what would you say is the added value of this new approach?
I mean, to address this the first question, I mean, technically, it would be possible, I think, to distinguish between looking at the camera versus looking at the actual audience. But for that, you would need to know where the camera is actually placed at. I would assume it's like a bit above the audience potentially, but I don't know it, to be honest, and it's also quite difficult to infer from the speeches itself. But technically, it would be possible because there is it's a very precise approach, at least in terms of if you look at different validations from these models. So yeah, would be possible, would be something which might be interesting, or just also setting a threshold, basically. Okay, this is looking at the audience, this is looking at above the audience, either it's the camera or probably something else. This is the first point, and also like this idea of thinking of, okay, potentially they do not like just looking straight at, but they look at the camera, which might be an explanation. But then again, why should female MPs, I mean, it might be, that female MPs are just more inclined to talk to the audience that sits not in the parliament, but opens up another box, I think. And then second, why do we need a new measure? I mean, if we look at these sentiment results, these results are only possible because we have this directed measure. If we just use text, we do not really know, okay, was this sentence addressed to the AfD? or to a competing party in that scenario, or to our own party. We just don't know it because quite often it's just a sentence and no party is mentioned in the sentence. So this is where, at least in terms of sentiment, where seeking eye contact comes in, because it allows us to associate sentences or even words in speeches with parties these are directed at, basically. So this is where I see quite a big merit, not only for sentiment, but also for gaze direction itself in isolation. And I think like this directing component is just something you probably won't find in a lot, like in text only. I mean, you can extract and you can look for party names. I also did this in the paper. I basically correlated mentions of parties in text, or of the AFD. I did it with the AFD in a text and correlated this with seeking eye contact with the AFD. And there is not that much of a correlation between both of these, because quite often the AFD is mentioned, but parties just talk about a proposal of the AFD or whatever thing that relates to the AFD, but they do not really talk to the AFD. They probably talk about the AFD, for example. Yeah, which are two things.
Yeah, but then the question is, which is the one that's actually more relevant, right? Because let's say you have, let's say the AFD in the opposition, they've just attacked you as a governing party, and you speak to them defending the merits of what your government has achieved, right? Then is this a statement? I mean, it's a statement directed to the AFD, but about your own party within, your coalition. So there's a good chance that the sentiment is going to be positive because you're stressing everything you've earned. Perhaps then in the next sentence you will attack the AFD and debunk their criticism. But I mean, there's different information then, right? In the textual or content of your speech and the recipient whom you address it to. So, I mean, I guess with the data you have, you can kind of look at the interaction of these two spheres, right?
Yeah.
What or whom you talk about and who you address it to.
Yeah.
So that might be like an interesting or promising next step, though.
Yeah, absolutely. Yeah. So no, I agree. I mean, this is really about, I'm really interested in like interactions with other actors and parties, and not only in in particular in these mentions, basically, or talking about parties. But I agree. I mean, yeah, you could just combine both, basically. Yeah. Thank you.
I think this question of where the camera is an interesting one. But I don't understand the methods completely, but assuming, since you can understand which way they're looking in this direction, presumably you should be able to do it in that direction as well, whether they're lifting their chin or not. And if you think about the way that the Bundestag is shaped, you've got the MPs on a more or less equal level to you, but the camera is 4 or 5 meters above you, if I remember correctly. It's set up on the platform. You've got the public galleries around the edge here, and then the camera in the middle. And so maybe you can tell whether they're looking at the camera based on whether they're looking upwards. Like you said, with the, maybe trying to access people on social media and that kind of thing. But also it seems feasible that, I don't know for sure, but it seems feasible that people could be also talking to the public in the public gallery when they look left or right. And perhaps then that up or down dimension might be helpful as well. But I haven't watched the German Parliament much because I don't understand what they're saying. So I haven't got any context for you about whether they do look up. I also had a question about the graph in the first paper you showed. I thought that was really interesting how you're collecting data on this sort of low-level stuff that might be ignored otherwise. Yeah, this was the one I was trying to understand this graph exactly. Am I misunderstanding it, or when you have only 10% of the members of the board are women, still half the time speaking time is taken up by women? Am I misunderstanding that, or is that correct?
No, that's correct. And this is but this is mainly because there are public comments. There are like different other actors that speak during these meetings.
The audience as well as the board members.
Yeah. Okay. Yeah. Like this is the main driver of this.
So are you able to infer that when a woman is leading the conversation, is that what the superintendent is, the chair of the meeting? So then they pick on more women in the audience, or is it that they ask other women on the board to speak?
I mean, they do not really ask them in a way. I mean, it happens in the end. It happens quite naturally, and they like if you want to speak during a public comment, you can just go there and ask whether you're allowed to speak. And one mechanism I would see behind this, and this is something that needs to be tested, is like the idea of having more women all in the school board itself leads probably also to more women speaking up in public comments, for example. So this would be something I would be interested to take a look at. So they feel more like encouraged to go there and give a speech and talk about their topics they're interested in. And I mean, another thing which could help to make this plot and this figure or this application more clear would be also, I mean, we could use our agenda item generation and just include all sequences that do not really relate to things that go beyond the school board actually itself. Like, for example, just include action items and nothing else. So this would be a thing to potentially reduce this number here. Yeah. But right now it's like an overall approach. And your camera question, right? So, I mean, the number of persons that attend, of citizens that attend these meetings is correlates closely with also how important these debates are. So quite often there are not that many persons sitting up there. And nevertheless, this is something which I could quite straightforward, I think of exclude from my models, because you mentioned it, right? I have all these 3 angles, like also tilting the head, for example, which is the 3rd angle is included in this measure. But just setting a threshold up there might help to at least include some of this, but it will also exclude some of this, but it would then also exclude the looking at camera position. So it would help in 2 fields, basically. Yeah, but that's a good point. Yeah.
Just related to what Dennis said earlier, it seems like once you have this relational structure and you put it together with the text that is being spoken, that would open up just incredible questions. Not just okay, what's the sentiment they're using, but are they engaging in actual arguments? I don't know, are they using humor, sarcasm, and when are they deploying it? All these questions. I'm just curious. Have you started looking at the text? What are they doing when they're facing another party?
Yeah, I mean, this is something we're currently starting with, also with this project, to go more into depth. Think of it like coalition signaling, for example. But I have not started to look more in depth into this. But yeah, this would be the next step to also combine these multiple modalities in a more thorough way, basically. Yeah, but that's a very good point, definitely. Yeah. And also to basically enhance unimodal studies, right? I mean, you could potentially think of replicating unimodal studies in a multimodal way.
Mm-hmm.
Yeah.
Any more questions in the room, or yes,
if there's time? And I was thinking about Ollie's social science data lab from a year ago or something on specifically body movement and so on. And I thought, could you not combine or extend the eye contact thing with a more direct measure of confrontation, i.e. pointing at people, which definitely happens in the Bundestag, which would probably be the hardest form of confrontation, is pointing at people, heavily pointing at people. Not sure how easy that is compared to head angles, with elbow and hand positions in relationship to the body. But is that doable?
I mean, it is doable if you're just interested in okay, this person is pointing to the right and this person is pointing to the left. But if you're interested in, okay, this person is pointing at the AFD, I'm not sure. I mean, AFD would probably be possible if you just focus on the very right. Yeah, I mean, this really depends on how often this happens, right? I mean, it happens quite sometimes. But yeah, I think it gets more and more like less precise, I would say. And it's quite challenging. I mean, head pose is so like a very, I mean, it's a solved task, right? In computer vision. They carefully validated all of this. They implemented like sophisticated models, tried a lot. But I mean, pointing at persons, it's probably, there are lots of models definitely that can like are capable of extracting this, of labeling this. But I think this is less about direction than I think, more about whether someone is pointing or not. I don't know, like at least not a precise direction. Yeah. But yeah, I mean, this is one merit of legislative debates because you have this high quality data, right? If you have the model, I'm pretty sure that this is possible at least. Yeah, because the video quality is good enough. Yeah.
Right. More questions in the room or online? No. Well, in that case, let us thank Andreas once again for the excellent presentation and for coming here.
Thank you.
And we will be back with the next event of the Spring 2026 series in the Social Science Data Lab on April 22nd, when Lea von der Heide will present her work on using large language models for coding open-ended survey responses. Thank you all for being here today. We hope to see you next time.